Okay, so radical equations. So we can actually solve, if we have a radical equation, we can solve it. So first things first is you want to isolate the radical. So that just means get the radical by itself on one side of the equation, everything else on the other. You don't want, you're trying to avoid having like something being added or subtracted to the radical. And then you're going to raise each side of your equation to the power of the index. So if you have a square root, you're going to raise each side to the second power, cube roots raised to the third, fourth roots raised to the fourth. This is going to cancel your radical, and then you're going to need to just solve the remaining equation left for x. And you want to check your solutions for any extraneous solutions. And remember, extraneous solutions are just solutions to the equation that when plugged back in, don't make it true. So let's start with these two examples. So notice on this left one how we have our radical right here. We have a square root, but we have is plus 10. To isolate, we're just going to subtract by 10 on both sides to move it over. 11 minus 10 is 1. Now that the radical is by itself, you want to raise both sides to the index. And in this case, our index is 2. So we're going to raise both sides to the second power. Doing this eliminates our radical, leaving us with a plus 7 on the inside. And 1 squared is just 1. And then you just solve for a. Getting ahead of myself. You would subtract by 7. 1 minus 7 is negative 6. So once you get your solution, to check it, you would just plug it back in. So in this case, you would just take negative 6 plus 7 plus 10 equals 11, and just check to see if that's true. So in this case, negative 6 plus 7 is 1, and the square root of 1. So you get square root of 1 plus 10 equals 11. Square root of 1 is 1. And you just ask yourself, is 1 plus 10 equal to 11? In this case, it is. This checks out. It's a true equation. So this is a true solution, and you would just box it. We'll see an example of a non-true equation. So if we look at the second example over here, notice how both sides of our equation are underneath the radical. There's nothing being added or subtracted. They're both by themselves on their side. So we would just start by going ahead and raising them to the second power. This stands like this. Since they're both square roots, this cancels them and leaves you with u minus 8, which is then equal to 43 minus 2u. And you just solve for u. So what you want to do is get your variables to one side. I always move the smaller variable to the other side. This gives you 3u minus 8 equals 43. And then we just add by 8 because we want to do the opposite. This gives you 3u equals 43 plus 8 is 51. And then you just divide by 3. U is 17. To check this, you would just plug 17 back into both u's, and it's actually going to make this equation true. And when you plug u and 17 in, it makes it a true solution. So this would be your answer, and you would just box it in. I will warn you about which two you need to check solutions for, because they're going to have extraneous solutions on that. All right, let's look at this example right here. 2 square roots of 6w minus 5 equals negative 14. As you can tell, your radical sign is not on its own. It has a 2 right here attached to it. So since this is 2 times the square root, you would just do the opposite. Divide by 2, divide by 2. This gives you the square root of 6w minus 5 equals negative 7. Now that the radical is by itself, we're going to square each side. This is going to give you 6w minus 5 because the square root cancels the square. Negative 7 squared would give you a positive 49. And now we're just going to solve for w using algebra 1 skills. So we're going to add by 5 on both sides. This gives us 6w equals 54, and then divide by 6, which gives us that w equals 9. And you're going to want to check this one. I'm going to write CK, by the way, for check. And when you plug this back in, you go back to the original equation, choose square roots of 6 times 9 minus 5 equals negative 14. And you can use your calculator for this. And you can plug this left side in, and to make this equation true, we need to get negative 14. I'm going to do it by hand. So 6 times 9 is 54, minus 5 is negative 14. 54 minus 5 is 49. And then the square root of 49 is 7. And 2 times 7 is 14 equals negative 14. And you ask yourself, is this equation true? Does 14 equal negative 14? In this case, it does not. So w equals 9 is not a true solution. It does not make this true. So you need to solve for it, and you just draw a line through it to say that it's not true. And since the only solution we found is not true, this means that this is a no solution. That means there's no solution that you could ever find that's going to make this equation true. And that would just be your answer. Let's look at this other example up here. So let's say we have square root of 12 minus 8 equals a. So notice how your radical's all by itself. So you're going to square both sides. And you get 12 minus a equals a squared. And now it's important when you have a squared variable to move everything to one side of the equation. In this case, we're going to move everything to the a squared side. So we're going to start by adding by a, and then we'll subtract by 12. And so it's going to give you a squared plus a minus 12 equals 0. And it's important to get it to equal to 0 because now you have a trinomial, and the only way to solve for a trinomial is to double parentheses it and factor. So we're going to put our a on the left side because we have a squared, so we need a times a. And you need 2 factors of negative 12 that combine to a positive 1. So since it's a negative 12, this tells you need a negative and a positive. And 2 factors of 12 that combine to 1, since they're opposite sides and you have a difference of 1, this would only give you 3 and 4. Since it's a positive 1, you need the bigger factor to be positive. So negative 3 times a positive 4 is negative 12, and negative 3 plus 4 is a positive 1. And from here, you're going to set up your t-chart, and you're going to set each factor equal to 0. And then just solve for a. On the right, when we have a, we would subtract by 4 to get a equals negative 4. On the left, you're going to add by 3 to get a equals 3. These are our 2 solutions. And now we just check these solutions. Since there's 2, you're going to have to check both of them. So you're going to do 12 minus 3, and this has to be 3. So square root of 12 minus 3. 12 minus 3 is 9. And right here, you can ask yourself, does the square root of 9 equal 3? And this is a true statement. The square root of 9 is 3. So you would box it because it's a true solution. And then you would check negative 4. Square root of 12 minus negative 4 equals negative 4. Minus a negative is plus. So 12 plus 4 is 16 equal negative 4. And you ask yourself, does the square root of 16 equal negative 4? If you're unsure, you could always take the square root, and you'll see that it gives you 4 equals negative 4, which is not a true statement. This is not true. So negative 4 is not a solution. And only one of we found 2 solutions, but only one of them worked, which is fine. Sometimes, no matter how many solutions you find, all of them may work, some of them may not, or all of them will work. It's a difference. As long as one of them works, you have a solution. Had none of these worked, it'd be no solution again.